I am Ennemcien. Welcome to Q-Master. First question. A square loop and a circular loop of equal area are withdrawn from a uniform magnetic field perpendicular to the plane of each loop with the same velocity. Will the induced EMFs be equal in magnitude? That is the question. Here magnetic fields are shown to be perpendicular to the paper and directed into the plane of the paper. That is why we are representing the field by crosses. This is a square loop. This is a circular loop. Both have the same area and both of them are moved out of the field. Then induced EMF will develop. Will they be equal? That is the question. A length of each side of the square loop is L, so that its area is L square. A equals L square. Area of the circular loop is, if radius is r, it is pi r square. The two areas equate the two areas. L square equals pi r square, from which radius of the circular loop r equals L by root pi. Now the flux linkage, since B and A are equal, flux linkage is B into area. So phi flux linkage equals BA, same for both. Now time, if this square loop is to be taken out of the field, its displacement, it must be given a displacement L to come out of the field. At the same time, the circular coil must be moved through a distance 2r to come out of the field. Both the coils loops have same velocity. So we can find out the time required to pull them out of the field. Time for the square loop T1 equals distance moved is L by V, distance by velocity. Time for the circular loop T2 equals 2R by V. Distance must be equal to diameter, then only the loop will come out of the field. So 2R by V, that is 2 into R is L by root pi into V. Now 2 by root pi is greater than 1. This is square root of 3.14, that is less than 2. So 2 by root pi is greater than 1. So T2 is greater than T1. Therefore, induced EMF, which is the rate of change of flux linkage, is BA minus 0 by T. When the coil is out of the field, of flux linkage becomes 0. Initial flux linkage is B into A. So change in flux is BA minus 0. That divided by T. This is the rate of change of magnetic flux, and this is equal to the magnitude of the induced EMF according to Faraday's law. So in the case of square loop, induced EMF is BA by T1. That is, and in the case of circular loop, induced EMF is BA by T2. Since T2 is greater than T1 or T1 is less than T2, the denominator is less in the case of square loop. That means EMF induced, the square loop induces more EMF. That is the answer. You can work out yourself using these castings. Next, another problem. Draw the power triangle for an AC circuit. A small question. Power triangle is a right-angled triangle, base of which must represent the actual power or wattful component, and the altitude must represent the wattless component. So base, this is the power triangle. The base is Vi cos phi. This is phi. Altitude is Vi sin phi. Then the hypotenuse will of course be V into I, because this is equal to square root of this square plus this square. That will be V into I. This is the apparent power. This is the actual power. And this is the wattless component of the power. This diagram is called power triangle. That's all. Next, compare electric field and magnetic field. Electric field is produced by either a charge at rest or in motion, whereas magnetic field is produced by a charge in motion. A static charge will not produce magnetic field. Second point, electric lines of force has a source and a sink, because you can separate positive charge and negative charge, or you can isolate positive charge and negative charge. Electric lines of force originate from positive charge and terminate at negative charge. There is a source and a sink. On the other hand, magnetic field lines are always closed. They don't have either source or sink. Then, that means there is no magnetic monopole. You can't separate North Pole and South Pole as a separate entity. So, closed magnetic field lines means that the non-existence of magnetic monopoles. Another point, force on an electric charge exerted by magnetic field is always in the direction of the field or opposite to the direction of the field, depending on the sign of the charges. And the field will exert this force whether the charge is at rest or not. On the other hand, magnetic field exerts force on electric charge only if the charge is in motion. These are the essential differences between electric field and magnetic field.